Silence your cell phones now, please. Okay. Hello. I'm going to do a little video on probability here. I have to lend me a wonderful aid, a little basket of colored balls. And so there's various colors in here, and there's more of some colors, and it'll make sense in about 3 seconds. So what we're going to do is we're going to find the probability of certain events using these colored balls. So what we're going to do is sort of the simplest thing to get started. We're going to find the probability of if we picked one, what we picked would be, one of the colors. So there are 5 different colors. There's yellow, blue, orange, purple, and green. There's 1 yellow, and there's 15 overall balls. So the probability of getting yellow would be 1 out of 15. So we mark that up here, 1 out of 15. And then we're also going to write the odds of getting that. So that's right below, so that's 1 to 14. So odds is success over the whole number of probabilities, and odds is the number of successes to the number of failures. That could happen. So blue. So blue, there's 2 blue balls, so that's 2 out of 15, or 2 out of 13. 2 to 13. Purple is 3 out of 15, which simplifies to 1/5. And then the next color is orange. So that's orange is 4 out of 15, or 4 to 11. And then the last color, last but not least, is green. 5 out of 15, which simplifies to 1/3, or 1 out of 2. So these are the single probabilities and odds of all the different colors. Okay, so I hope I wrote those down, because we're going to do something with those, and you're probably going to need that. So what we're going to do is we're going to look at the probability that if you choose 3 color balls, what are the chances that all of them will be orange? Okay, and so we're going to do this with and without replacement. So if you do that with replacement, you're going to be looking at basically 3 separate events. Okay, so because you're going to choose one, that's the first event, put it back, choose the second one, that's the second event, put it back. 3 separate events, and what it's going to be is, so since we're doing probability, it's going to be the number of successes to the choices. So since there are 4 orange balls and 15 overall balls, it's going to be 4 out of 15. So that's the first one, 4 out of 15. And it's going to be the same for the second trial and the same for the third trial. So if you write that down algebraically, it means it's going to be 4 out of 15, or write it down numerically is what I mean to say. 4 out of 15 times 4 out of 15 times 4 out of 15. And that is the same as 4 out of 15 cubed. Because with replacement, the balls don't go away, so there's not like less orange balls afterwards. So 4 cubed, grab my calculator, handy dandy calculator. 4 cubed is 64. Some of you probably already know that off the top of your head, because you're just so smart. And 15 cubed is 3,375. And I don't think that that's simplifiable. That's going to be the final answer for that. So 64 to 3,375, that was with replacement. So if you were going to look at without replacement, it's going to be a little bit different, because you can still think of it as 3 separate events, but I sort of think of it as one and the same, because you can choose one and then choose another one and then choose a third one, but it's also sort of like choosing 3 at the same time. What that means in terms of the probability is that rather than just having this simple fraction that we multiply 3 times, it's going to change. So it's going to be 4 to 15, and then the next one, there's only going to be 14 balls, and if you got the green ball before, there's only going to be 3 green balls. So it's going to be 3 out of 14, and then 2 out of 13. So we multiply that out, 4 out of 15, because we have all of the balls. And then if we choose the green ball, we get 3 out of 15. This is a multiplication symbol, I'm sorry, it's a little rushed. 3 out of 14 times 2 out of 13. And you can simplify that, 1, 7, that's pretty much all it simplifies. So that ends up being 12. That's definitely not a 12. You get 12 out of... I do not know what 15 times 13 times 7 is. I'm sorry, I am not the mental math whiz that some of you may be. That's going to be 1,365. So the final answer is 12 out of 1,365. There's a probability of, without replacement, of getting all green balls if you choose 3 of them. Whoa. So next what I want to do is I want to say, if I had all these balls, if I had like a little track, right? A little track and it held all these little balls in it, how many distinct different ways could I arrange all these balls, assuming that the ones that are the same color are effectively the same? So this is sort of like another problem you may have encountered in your homework, where they give you a word and they ask you how many ways you could form the letters around. So what you're going to do is you're going to say, okay, if all of them were completely different, how many different ways could you arrange them? And that would be whatever the number of balls you have, factorial. So we have 15 balls here, so it's going to be 15 factorial, because if you think about it on a small scale, like if you only had 3 balls, you could have any of them for the first one, so that's 3 times, and the next possibility you could only have, there's only 2 different possibilities because your first place is already determined, and the last place only has 1 possibility because there's only 1 ball left. And that is effective, and that's 3 factorial, 3 times 2 times 1. So we have 15 factorial as the numerator of our fraction. And I say numerator of our fraction because we need to make a fraction, because obviously in this case not all the balls are distinct. Some of them are the same color. In this problem we're assuming that they're the same, and that if you put them in a different order it makes no difference. So what we now have to do is we have to divide this by the number of balls that are the same color, factorial. And then I'll take out all the possibilities that are the same. So 15 factorial divided, and ours go, the balls I have here, there's 1, 2, 3, 4, 5 of each color. So I'm going to discount the first one, the yellow ball, that's only 1 because it's divided by 1, it's the same. So it's going to be 2 factorial times 3 factorial times 4 factorial times 5 factorial. Okay, so now that we have this whole fraction here, we're just going to evaluate this with a calculator. It's 4 factorial. The answer to that is 378,378,000. So that's 37,837,800 distinct possibilities with these different colors. Okay, so I've written all the probabilities for the different colors up here for our last and final part of the problem, which is going to be, we're going to find various probabilities of other different events using and or. All the events here are mutually exclusive. So when 2 events are mutually exclusive, it means that you can't have both events happening at the same time. And that may sound a little weird, but it basically means that, so I'll give you an example. So if you're looking at cards, right? You cannot have a card that's both a 3 and a 2, because each card only has 1 face value, and it's that face value all the time. So the same thing with these balls. These balls aren't changing color. They're not 2 colors. They're 1 color. They're either green, they're orange, they're purple, blue, or yellow. So what that means is that it kind of makes it a little bit simpler, because if you looked at this in terms of a Venn diagram, they would never overlap. All the blue balls are separate from all the green balls, and they never touch. Or if you think of it like a street, like 2 streets. So some people like to think of it as 2 streets, so if they intersect, then the things that are in the center in the intersection are things that are both events. So these would be parallel streets that would never cross. Let's say we wanted to find the probability that we pulled the ball and it was either green or yellow. So if we look at the probability of getting green is 1/3, the probability of getting yellow is 1/15. So what we're going to have to do is we're going to have to add them, because the probability of getting 1, and so that would satisfy our pass-fail requirement and the other one would also satisfy our path fill requirement, so we would add them together and would give us, the OR. So, 1/15 for the yellow, and we're adding it to the 1/3 of the green. We can just multiply this by 5, so that's 1/15 plus 5/15, and that is 6/15, which is, and that's simplifiable by 3, so that is 2/5. So the probability of getting either green or yellow is 2/5. There's a technique that you can use in probability to find the probability of something not happening. So what you can either do is, say if I wanted to find the probability of pulling one and getting neither purple or a blue. So what you would do in that situation, you could add up all of the probabilities that aren't getting purple or blue. So instead of saying, what's the probability of not getting purple or blue, what's the probability of getting a yellow or an orange or a green? Or what you can do is, because you know that the total probability is going to add up to 1, what you can do is you can say, you can take the probability of 1 and you can subtract the probability of getting what you're trying not to get. So I'm going to make this simpler by just doing it. So if you take 15 out of 15 and you subtract the probability of blue plus probability of purple. So probability of blue is 2 out of 15, probability of purple is 1 out of 5, which is 3 out of 15, so that's minus, so 2 plus 3 is 5, so that's 5 out of 15. So 15 out of 15 minus 5 out of 15, 10 out of 15, and you divide that by 5 to simplify it, and we divide it by 1, but 5 over 5, and that's 2 out of, gosh, I am just a mess today. 2 out of 3. So we have that 2 out of 3, so I'm going to put that on the side here, 2 out of 3, and we're going to verify this. I'm going to show you that it actually does work by adding up the probabilities of all the other events. So 1 out of 15, so everything except for blue and purple. So 1 out of 15 plus 4 out of 15, which is the orange, and then the green is 1 out of 3 times 5 over 5 is 5 out of 15. So 1 plus 4 plus 5 over 15. And 4 and 5 is 9 plus 1 is 10. And that equals 10 out of 15, which is the same as 2 over 3. So you can see that these are indeed one and the same. I hope you learned a lot, and I explained some things in ways that you could understand them. So that's it. Probability is exciting, I guess, is the moral of the story here.